Next question. Question number 12. A particle is executing simple harmonic motion with a time period t. At time t is equal to 0, it is at its position of equilibrium. The kinetic energy time graph of the particle will look like. 4 options are given here. We see how to solve this sum. See, the particle is executing simple harmonic motion. First we will see how to solve it by applying some thought, not trying any mathematical expressions. Just see certain ideas how to apply, how to solve this. Because it is executing, the particle is executing simple harmonic motion, we can take a very standard example of simple harmonic motion and apply the idea to it. Say a simple pendulum you take. This is a simple pendulum. When time t is equal to 0, the particle is here. Time t equal to t by 4, let's say the particle has gone there. It oscillates. This is one oscillation. Here to here, here to here, t by 4, from here to here another t by 4. Here to here another t by 4, here to here another t by 4. So from the starting point, here to here t by 4, t by 2, 3t by 4, t. When time t equal to 0, it is crossing the mean position. So it has got a maximum kinetic energy when time t is equal to 0, when it is vibrating. Kinetic energy is 0 when time t is equal to t by 4. The reason is it has to stop momentarily and return. So what is the idea? When time t is equal to 0, kinetic energy should be maximum. Look at the possibilities. When time t is equal to 0, kinetic energy is 0, so rule out this. Look at this. When time t is equal to 0, kinetic energy is 0, so rule out this. Look at this. When time t is equal to 0, kinetic energy is maximum, fine. But the kinetic energy is going to 0 when time t is t by 2. That is not possible. Because as it oscillates, time t is equal to 0, kinetic energy is maximum. Time t equal to t by 4, kinetic energy is 0. So t by 4, kinetic energy should be 0. Now look at this. Time t is equal to 0, kinetic energy is maximum. Time t is equal to t by 4, kinetic energy is 0. Again when time t equal to t by 2, kinetic energy is maximum, and so out of all the 4 options, this option is fine. Within the given options I am saying. But if you want to approach it in a mathematical way, use the formula for kinetic energy. You know y is equal to a sin omega t. Okay, for this formula. Then velocity a omega cos omega t. Half m kinetic energy, half m v square, half m v square a squared omega squared cos squared omega t. So basically the graph should be a cos square omega t graph. Maximum value of the kinetic energy being half m a square omega square. Maximum value of the kinetic, because this is expression for the kinetic energy. Expression for the kinetic energy. So what should be the graph look like? What should be the graph like? So what should be the graph like? It should be a cos squared theta graph. Cos squared graph would be like this out of the given choices. But if you want to have more, or if you want to have a better graph for cos squared theta, it has to be like this. Okay? or omega t. This is kinetic energy. Because here the slope should be 0, here the slope should be 0 if the function is to be a cos square function. But out of the 4 choices given, this one will be the answer. Thank you.